and we'll just go around. Everyone can give quick updates, and then I think we'll hear from Larry, and he can tell us all about what he's been doing, because he's been quite busy trying to do a radio propagation study project across the Pacific.
Oh, wow.
Yeah, it should actually be really fascinating. And he's been very busy emailing lots of Japanese scientists and amateur radio operators trying to get support. And he's been sending me emails as well. And I've been doing my best to keep up with them. So yeah, so hi everyone. Things are going fine here in Scranton. We are on day 4 of classes. I am teaching a digital signal processing and introduction engineering class this semester. In the intro to engineering class, we're actually going to do an introduction to amateur radio and have them do a space physics paper. So I'm going to go to all 3 sections of the class next week and give my introduction to amateur radio and space physics and teach all of them how to listen to sideband signals on the Kiwi SDRs. And then tomorrow we have the club fair. So we now have a whole stack of these nice advertisements to hand out to students, flyers, advertising ham radio. And so she's our club president. She's designed these actually. She'll be there, and a number of our other students. And we just ordered a brand new Buddy Pole deluxe package that arrived promptly at noon today. And so we're going to set that up in the gymnasium and have it up nice and tall. And, so we should be able to really attract students from hopefully far away on the other side of the gym. And our local county Aries emergency coordinator, he's going to be with us tomorrow too for the club fair. So I think it's all going pretty well. So that's what's going on here. Mike, AA8K, go ahead.
Greetings to everyone listening. Back to you, Nathaniel.
Thank you very much. How about John, N8OBJ?
My name's John, November 8, Oscar Bravo Juliet. I am the lab director for the undergraduate design circuits lab at Case Western Reserve University. That's my day job. Previous to that, I was an analog design engineer for Keithley Instruments and specialized in electrometers. I am in process right now of designing the hopefully low-cost personal space weather station Gen 2. In the process of getting pieces of that put together and working. Gen 1's been out there and was not originally intended to be distributed, but they distributed it anyway. And I'm still pulling my hair out. I had a full head of hair when I started this project, so. So I'm in the process of building parts for that and getting it. And I have a new volunteer programmer, Bob Benedict, who offered to come online, who has done, I think he was at GE for 10 or 20 years doing C++ programming and Python coding. So he's the perfect match for what I'm looking for. So I'm really hoping to get a lot of stuff done now that I've got that major burden. I can code, but I'm a EE analog design engineer. I'm not a software person. So he can do things 10 times more efficient and 20 times faster and make it work better. And mine's kind of, I can modify code, but I'm not good at starting from scratch. So anyway, that's sort of where I'm coming from. Back to Ned.
Thank you very much, John. Over to Dev, KC3 PVE.
Hello, good afternoon, everyone. So as we're alive and kicking here in Scranton, and I think I made some progress in my research, and we want to now dig into the science part and try to squeeze some science history out of it so that we could try to write a paper out of it. Thank you. Back to Ned.
Thank you very much, Dev. Over to Bill, AB4EJ.
Thanks, Nathaniel. I've been busy doing a couple of things. I just re-recorded for about the 3rd time my DCC presentation on magnetometer RF testing. I had a nice version of it last week, but then I lost it somehow. I don't know where it went, but anyway, all I had to do is re-record it again. So we got that ready to go. The other thing that I've been doing that's of interest, and I explained this a little bit to the Case Western Reserve team this morning, is doing some work with the magnetometers. I've got 2 magnetometers installed, and I did some recording of both of them and comparing them. Let me show my screen, and I can show the group what I'm talking about here. This, okay, you got it? You see it?
I see it.
Okay, so the blue line is magnetometer 1, and you can see what apparently is a diurnal change in it as we go through the day. And here's magnetometer 2 is the orange line, but look how they don't really line up. 2 interesting things about this is the fact that they don't line up, and this Batman bat signal kind of thing that we see out here, and also this little glitch right here. So I started wondering, well, what could be causing these to diverge that much? So then I plotted the temperature down on the downhole instrument and recognized that, okay, the magnetometer 1 is on the side yard, which is a sunny location. So it's getting warm and then it's getting cool, and that is affecting the readings quite substantially. Magnetometer 2 is in the front yard, which is shady most of the time. So one of the recommendations we can make, obviously, is excellent insulation, but also if you can find a place that's shady all the time, that's much better for your magnetometer. I believe these little glitches here is when it rained and it dropped the temperature, and then it happened again. So you see a little bit of that in the signature. Nathaniel, you told me to look at the NASA Omni satellite. As of today, it only goes through August 26th. So I've got a couple of days. This is from August 29th, these data, and we will be taking a look at that to see if this bat signal here is actually due to coronal mass ejection. I went through and also compared what I'm getting to the closest USGS instrument to me, which is New Orleans, and they got a signal it's got a lot in common with these, and you also see that same bat signal. So we're getting real data off these magnetometers, and I believe can be used to do some real science, because it's close enough. It's close enough to what the USGS is getting that I believe the data coming off of these devices. So that's what I've been up to. Back to Ned.
Thank you very much, Bill. That looks good. It also really highlights yet again how important that temperature variation is. All right, let's go
And
over
the one
to.
variation was only 1/10 of a degree, and it still showed up.
That's right. It was less than 1/10 of a degree.
Yeah, so we've got to really do our homework on the thermal construction of this box.
Yeah, I agree. Yeah, less than 1/10 of a degree. That is kind of scary. All right, so it looks good. So let's go to Dave W60Q.
Good noon here from sunny California. I'm just here to see what's going on and maybe figure out something I could help out with. But right now I have very limited bandwidth.
Very nice to meet you. Thank you. How about David, AD8Y? We'll come back to David in a minute. Tom, N5EG.
Well, good afternoon. Trying to learn everything I can learn about FPGAs. And my gosh, it's a steep learning curve. Back to the group.
Thank you very much, Tom. Sounds good. Let's see, David McGaw, N1HAC.
Hello, everyone. I'm mobile right now, so hopefully the cell connection will work. But I'll just introduce myself. I've got actually dual citizenship. I've got a position at Dartmouth and a position at NJIT doing polar research and auroral research of various sorts. We use SDRs all over the place, ground-based and rocket-based. And I'm working on Korean automated geophysical observatory. And then, you know, avid ham and very much into this idea of using our signals to probe the ionosphere. So a lot happening these days. Back to Nat.
That sounds good. And for those of you who don't know, that Korean AGO project, that's also one that Hyomin's in charge of here on the US side. So that sounds great, David. And I'd like to welcome John Hayes from Ardc. Hi, John. Welcome.
Sorry I'm late. I noticed your invitation and thought I'd pop in and be an observer today.
Thank you. Yeah, this is our first Telecon back after a summer vacation from Telecons for the main HamSCI group. So we're starting off a little small today, but I think we have a good little group. It's nice to see you. And let's see, and then finally, Larry, go ahead.
Hi, I'm Larry N6NC. I'm in San Diego, California. I'm a retired lawyer and law professor. I have been a ham for 62 years. Only started contesting maybe 25 years ago. Second time out, we won the ARL DX CW World Multi-2 from Ensenada, Mexico, 60 miles south of us here. So anyway, that got me started in that. But specifically for these HamSCI projects, I've noticed in 25 years of contesting that we generally have, or I'll say 50% of the time, we have very good propagation to Japan, CW, in the contest weekends in the mornings from local time here, maybe 5:30 to 7:30 a.m. I've worked with Carl K9LA to try to figure out what this propagation might be and physically how it's happening. I went back to school a couple of years ago and got a master's from Scripps Oceanography at UCSD. And I'm kind of interested ultimately in the physical causes of these various propagation enhancements. The problem over the Pacific is that there are no zero ionosons now, so it's very hard to sound out the F2 layers all the way across the path. Carl has told me that for 7 megahertz, which is the frequency I'm interested in at this morning propagation, it's probably 4 hops, F2 hops. And I'm trying to figure out what the actual propagation bounce path is and what is causing that particular path to happen. I'm having a small beacon built by Hans Sommer, the guy that runs the QRP labs, for 40 meters, and we're still looking for somebody to site it here in San Diego. Nathaniel put me in touch with a couple of professors at universities in Japan, and one in Tokyo and another up in Nagoya in Hokkaido. The Tokyo professor has 2 CW beacons at 5006 kilohertz and 8006 kilohertz but they only run 160 watts and 60 watts. So I've been unable to receive them here. Nozomu-san, the professor up in Hokkaido, runs the Super Darn radar, HF radar up there. And I have been successful in painting on my SDRs, their schedule, which is on a very precise microsecond basis. They're very fast pulses, and that's all they're allowed to do under their Japanese FCC license. But anyway, what I've been doing is recording wave files of the actual received raw RF and then sending them to everybody on our particular list, they're enormous files, and we're still dealing with that. The professor in Hokkaido has opened up an FTP site for me in his university server, but we're still playing around trying to get the public key to work there. The two ideas I have are regular CW transmissions from both sides of the Pacific to the extent they can be received on the other side, particularly at the time in question. And I've spoken recently to Nozomu-san about the Super Darn radar, which according to the articles that he and Nathaniel sent me, are capable of doing angle of arrival studies and hitting at least some layers of the F layers. So what and Nozomu is planning but has not done yet a study with Pacific Coast North American Super Darn radars where they're going to be transmitting at each other and will be able to determine their elevation arrival angles of the signals. And the point of that is, if you know the arrival angles at both ends of the path, you at least know where the first F2 bounce is for maybe a 4 bounce path or so. And we're hoping that that'll give us some hint as to what's happening up in the ionosphere over the Pacific. If anybody's interested, I found an article by an experienced SWLer about tropospheric and modified tropospheric propagation. And I actually remember reading a paper from the Naval Research Lab here in San Diego from the 50s, I think it was, where they tried these tests on 13 megahertz and determined that because with a uniform temperature ocean, there's a physical layer of moist air that actually acts kind of like a duct. And at some point, this Tropo article suggests that there can be some kind of ducting and then ray breakout that then goes up to the F2 layer. So there's all kinds of complications here that nobody knows nothing about, and we're trying to figure some of that out. Back to Nathaniel.
All right, that is a lot going on there. So I think we will talk more about that today. I just saw, before we go on to that, I just saw one more person come on. Tulip, why don't you just say hi to the group and tell us a little bit, and then we'll come back to what Larry's talking about.
Just quick good morning. Just was able to sign in. Tulip Winslow, KV7DNS here in Houston.
Great, thank you, Tulip. Nice to meet you. All right, so yeah, so Larry's working on this propagation project, and you said that you it was something about a number of years ago that was the propagation enhancement that really turned you on to this, right?
Correct.
Right.
Do you want me to explain that?
Can you explain it one more time?
Yeah, when the CW skimmers started about 10 or 12 years ago, I set one up here and I had very good gain antennas at low angle, parasitic, 2-element parasitic vertical for 40 meters. That was aimed exactly JA and about a 10-degree takeoff angle. One Saturday morning, I got up and I used to leave the skimmer on that at nighttime to see what the trans-Pacific propagation was like overnight. And I got up on one Saturday morning, in fact, July 24th, 2010, and noticed that it had copied 141 JA call signs, which it normally didn't even do during an international contest. I was astonished, and they were weak but very readable, very clear and very readable. I asked some of you may know TAC JE1CKA. I asked him what was going on because there were no international contests that weekend, and it turns out that it was the JA Summer Domestic CW contests, plural, that the locals, the JAs, work each other around the islands. And what he said was remarkable, not that it was just 141 reported call signs in the skimmer, but that 85% of the stations were 5-watt stations. So it was really an unusual propagation event, and I always note things like that. Pursuant of that, I hired a student of one of my Scripps professors, and she's now starting to look into all the reverse beacon network archives for at least the contest weekends to see if there were any more episodes like this where there were contacts recorded by West Coast US skimmers, particularly San Diego, and JACW stations and stuff. So we're going to try to gather up all that data and see if we can find any patterns there. Again, what I'm looking at is if once we know there is an enhancement date, then I go and I look at the satellite photos, both visible and infrared for thermal and for even cloud patterns, those rippledy atmospheric gravity waves, which can cause ionospheric ripples and so on. And then there's a lot of other electronic data around that we're able to look at to try to see what was going on precisely at that time. Okay, Nathaniel.
Yeah. Any questions for Larry?
Well, it does occur to me that we could possibly use some of the other data we've been collecting, for particularly PSK data, because it's so voluminous. We might be able to see some of these phenomenon being reported in those data.
So
Just a comment.
Larry, Bill is, he runs the DX display website, which you don't quite keep active anymore, do you?
Oh, it's running. It's up and running.
It's up and running. Okay, so he runs DX display, and he does a lot with the data wrangling of the PSK reporter, the WSPRNet, and the RBN data. So, and he's also actually funded now to keep doing this sort of thing with the NASA grant that we recently got. So he's a really good resource in terms of knowing whether or not the RBN or WSPR or PSK reporter data is making sure it's geolocated properly, making sure that data is in a form that is usable.
Excellent.
So I think, so it sounds like the thing to do right now is keep going through that data and try to find the days where you have more similar enhancements.
Yes.
Yeah. How is that coming so far?
Slow. My student helper had to kind of get calibrated for all this stuff, but she's doing great now.
Okay.
I sent you some stuff. I don't know if you had a chance to look at it for one of your November 3rd, 2017 date. And she knows how to get the satellite data and the some of the other, we're also using the synoptic weather charts for the day, which show you the fronts and the winds and all that sort of thing to make sure we're looking at the thermal and other meteorological aspects.
Yes, I appreciated that a lot, and I can actually show that data, and I can show you what I've been working on in a minute here. I can bring that PowerPoint up and show that. So that was very much appreciated. In fact, we discussed, well, we got a chance to discuss my event, but we ran out of time before we had a chance to look at your weather maps on Monday. So we're going to have another session where we get a chance to do that. And your students welcome to come to these meetings at some point too, if you'd like to ask more questions or introduce yourself to the group as well.
Okay, thank you.
You're welcome. Yeah. Do you have are there any other outstanding questions you have, like from the emails, that I can answer now?
No, our only problem right now is getting this public key thing set up so I can dump those big WAV files to Nagoya University. I'm just having, I don't know very much about it, but using Wind SCR and Nagoya will not allow passwords. They'll only allow public keys.
Right.
And my setup won't accept the public key. It keeps asking for a password. So I called my IT guy today, and so hopefully we'll get that resolved in the next day or so.
Okay, that sounds great. Well, I'll work on, if you give me a minute, I can bring up the event that I'm working on here. But in the meantime, any more questions for Larry or any other discussion?
Just by the way, I went back and I looked at the temperature scale on the magnetometer data, and the temperature swing that I was seeing wasn't a tenth of a degree. It was about 1 degree Celsius. That was the temperature swing that was shown in that graph. So don't panic. We don't have to maintain tenth of a degree precision. So anyway.
Is that for the small one or for the big one? Because you had the big one looked like it was about 7/10 and the small one looked like about 1/10.
Oh, you're talking about the small one. Okay. I thought
Yeah.
you were talking about the big one.
Yeah.
Yeah. The small one, yeah, it's about 1/10. It's the big one is about a degree Celsius. So anyway.
Yeah, I ran
all.
into this exact same problem with a resonant ferrite source in a instrument, and it turned out to be a very good temperature indicator, and it had that kind of sensitivity. The mu of the material is very temperature sensitive, and it does wacky things. So obviously the mu they're using in their ferrites has a significant temperature coefficient to it.
I see Rob Robinette just came on too. Hey, Rob. So Larry, Rob Robinette is the other person who's also a WSPR database expert. And he actually has his own version of the WSPR database, which does a better job recording signal and noise measurements than the standard database.
Excellent.
Rob, are you there?
Rob, you'll have to close the garage door.
Okay, maybe we'll come back to Rob in a little bit. So let me share what I've been working on here. And I've shown some of these plots before, but then I keep working on them a little bit at a time and keep building on the earlier presentations. Let's see, that's one. You got the wrong, this one. So what I've been interested in are these large-scale traveling atmospheric disturbances that we can see in the RBN PSK reporter and WSPRNet data. And so you can see that over here on November 3rd, 2017. And so, oops, this is a little sensitive. Okay. And so along the x-axis here, we have time in hours, UT time, so going from 12 to 24 hours. So this is 12 hours of time. And then along the y-axis here, this is the distance between transmitter and receiver in the RBN, PSK reporter, and WSPRNet network. And then this is a two-dimensional histogram in 2-minute by 25 kilometer bins of all the data across the United States. This is the ham radio data midpoint distribution across the US. What you can see is as time goes on throughout the day, you can see that there's this wavy structure that goes along the bottom of the plot. And so what you're seeing is the distance between transmitter and receiver as a whole over the United States is moving closer and then farther away, closer and then farther away. And it has this periodicity of, say, about an hour and a half or so. And it gets a little bit longer throughout the day. And then you can see the same sort of structure in the super darn radar data in Blackstone, Virginia. So over here, we have, we're looking at data along this red beam here. This is slant range data, slant range away from the radar. And then here you can see these large humps. Those are also the same LSTID structure you see in the amateur radio data. And so the question is, where does this come from? That's what I'm trying to answer right now. And I'm still not sure. So one of the, if you read the literature, the major source for large-scale traveling atmospheric disturbances, they usually say, is the aurora. So what I've done up on top is I've plotted the equivalent, the supermag equivalent of what we call the auroral electrojet index. And this tells you, comes from ground magnetometers. It tells you how much current is in the auroral electrojets at a particular time. And so here you get a big spike up to around 600, 800 nanoteslas, and that's fairly active. And then it drops down for most of the rest of the day. And so you can see, and so what you'd like to see is you'd like to see that there's some sort of pulse here every time you see some sort of change in the wave structure down here. But you don't really see that. You just see one big hit, and then you see this structure over here. So I guess this isn't very satisfying to me, because maybe it's like you put energy into the system and then the system rings afterward, but that's ringing for a long time. And so I'm not really convinced that this is actually what's causing this, or I don't really understand it yet. To look at this a little farther, oops. This is the same day. It's just we're now looking at 24 hours worth of data. And so again, you can see a lot of auroral activity here before we see the TIDs happening. But once the TIDs are occurring, you don't see this. You don't see much auroral activity. I picked another contrasting day. So this is another day. This is a day in May where we also have amateur radio data, but you don't see any TIDs throughout the whole day. It's really quite a different day. But again, I picked it because I was looking for something that was contrasting when there was almost no TID activity. I was hoping to see that there would also be almost no auroral electrojet activity, but that's not quite true. There's actually quite a bit of auroral activity that day as well. So here we have the AE indexes again going up to about almost 600, 550 nanoteslas, and yet no TIDs.
Is that not supermag SME index? Is SME index same as AE index?
It's the same sort of index.
Okay.
It can be interpreted the same way. It's not exactly the same index,
Okay.
but it is the same type of index.
So
The
it is
supermag version, I think, includes more magnetometers. And the other thing it does is they will break the SME index up into regional local time sectors. So you can take this is spread throughout the entire polar auroral zone, but they can break it up into local time sectors using individual or groups of magnetometers. So you can see exactly what area is causing these big humps. So typically,
or what area are actually being affected by the auroral activity?
Exactly, yeah.
Yeah.
So here,
so these are affected. For example, the LO are affected. So they are, if they are between 4 to 8 magnetic local time, so those areas are being affected.
yes. Hold on.
Those areas, okay. No, no,
And-
no. I'm
and-
trying to see that if magnetic local time and UT time, that coordinate is sufficient to specify a geographical coordinate, geographical area, which is what you are saying.
Wait, say that again, Dev.
You are saying that magnetic local time for
Mhm.
this plot B,
Yes. Mhm.
because I had difficulty understanding, like when you were explaining it yesterday, I didn't catch it. Okay, so that's why I'm asking to it. So this magnetic local time and universal time
Yes.
for the plot B. Yeah, for the plot B. Okay, we can look at this because this has more of the SME.
This one's a little more clear, I think.
Yeah. Yes.
So wait.
So let's look at that. Yeah. Yeah.
Okay.
let's-
So
yeah.
so right here we see this peak here.
Mhm.
If you look down here, what this is saying is that you have a lot of energy here around 24 MLT and a lot of energy here around between 0 and 4 MLT.
That I see. My question is, okay, we have a lot of energy between 16 to 20 at 0 UT, right?
Yes.
So 0 UT and 60 to 20 magnetic local time. Does that correspond to a geographical area?
It does correspond to a geographic area, but you need to know where, but so the short answer is yes, it does correspond to a geographic area.
Yeah.
I can't tell you off the top of my head, is this like Greenland or is this Russia or is it Canada?
Okay, that's fine.
Okay.
That's fine. That was my question. Okay, so
Okay.
so it means magnetic local time and universal time is make good coordinate system to specify a geographical area.
Yes,
Yeah.
you can actually specify the geographical area using this coordinate system.
Yeah. Thank you.
But so right here it's showing that, but right now I'm not thinking of it that way. I'm just thinking like I'm seeing this spike and most of the energy is coming from the midnight to post-midnight sector, which would be pretty typical for, say, an auroral substorm.
Mhm.
So I guess looking at these two plots, I don't really know what's going on because this plot where you have almost no LSTIDs, we still have a lot of auroral activity.
Mhm.
So after doing all of this plotting and looking at all of these things, I'm still not entirely sure what is driving this.
So
And so
maybe
that,
I can take a guess. I can,
Yeah.
and I have a question. Okay, this is my question as well because in my research. Okay.
okay,
So this could be coupling from below. There should be some activity from below because auroral activity is coupling from disturbance from above, right?
yes,
So it could be disturbances. There could be series of disturbances which could be coming from below because there are various candidates which could cause this activity. I can name out of. Let me, if I can take a note, take a look at my notes. There are many candidates which could create that. Okay, it could be convective activity associated with tropical storms and hurricanes. Okay, this could be created by many sources. Okay.
yes, but whatever the source is, it has to be enormous because look at this video. So this is total electron content down here. You're going to start seeing that the TIDs come from up here. Here, everything's blue. And now everything's going to start turning red in a minute. So it's affecting the entire continent all at the same time, and it's progressing mostly equatorward. So whatever's causing it has to be huge. It's an enormous wave. So
let me read a sentence from Kelly's book. He says the detailed dynamics of Earth's ionosphere is governed by a complex interplay between motions of the neutral atmosphere, gravity, electromagnetic forces, pressure gradients, and plasma production and loss. So he says, like, for some reason the last letter two are not good.
there was another paper where like the possible candidates in that paper were mentioned. I don't have that on right very handy with me. It will take a few minutes for me to find out.
Nathaniel,
Yes.
if you look at when you get to the weather, the synoptic weather charts and stuff, you'll find that between your lines there, 110 west and 100 west, there's quite a different tongue of air down. The pressure difference on both sides is quite substantial, as is the thermal distance.
So that's what we're seeing over. So this is is this a thermal
The left side of that.
over here?
No, just the curve of the white clouds. Go right. Yeah, that edge, I think, is a protrusion of a different front.
Yeah.
Well, anyway, it's worth looking at.
So I guess, Larry, I don't have a lot of experience looking at these plots. Can you explain them a little bit more?
Well, there's obviously some clouds there. The point of that, I think that's the visible light, isn't it? Or is it infrared? What's the time?
It says band 3.
What's the time though?
1502 UT.
Okay, that's in the morning. That's like 8 o'clock in the morning on the West Coast.
Right.
Okay, so while I'm looking at the visible for atmospheric gravity waves, I don't particularly see them there, but maybe a little further north, up toward see those ripples? Yeah, that area, that might be. But if you look at the synoptic weather map that shows temperature and pressure and winds, that curve, let's see, is that the one?
Here's this. Okay, this is.
What time?
These are all surface analysis. That's
Right.
1200. Here's 1500.
Yeah, 15. Let's look at 1500. That's look, you got 1031 on the right side over what is that, Missouri? And then okay, and then right across around this tongue, it goes down to 1008. That's a big pressure difference.
Mm-hmm.
And then up here to the northwest, these lines are much closer together, which means, moving air front with a lot of wind speed.
Right.
And you can see the line, you can see the squall line here. See the red dots? Warm on one side, cold on the other side. The blue triangles are cooler air. The red are warmer.
Mm-hmm.
And the conventional wisdom is mere tropo weather doesn't affect communications. Personally, I think that's wrong, but that's the conventional wisdom. The ionosphere guys know ionosphere, the meteorological guys know meteorology, and generally they don't know anything very much about the others.
So there is lack of communication.
Yes, stovepiping, siloing.
Which I think more people are trying to look at that now.
Yes.
I know that's something I'm trying to look at, and I know a number of other people that I work with are trying to look at that too. So you were thinking, so it's really hard to tell to line this up. So you think there's something.
Go back to 1200Z surface analysis.
Right here.
There we go. Okay, isn't that where your dip is in your electron density or whatever dot chart?
There's a big dip right here. which I kind of thought was associated more with the terminator. But then it does become, the densities go up here, even though it's still in darkness.
Yeah, because here's the high pressure. That's well, I don't know either. I'm just saying
Yeah.
it's a good idea to look at these things at the same time as just the auroral and the electronic stuff.
Yeah, we didn't have a chance to actually go over these plots on Monday when we had the other meeting, but I think it's worth looking at them. It's hard to see like a one-to-one correlation. Like I can definitely see, all right, you kind of have this shape over here, and I kind of have this shape over here, but I don't know, it's very red over here, and I'm not really sure.
Okay.
So I think that's something. So Larry, I will be talking with those people, the MIT people and the Virginia Tech people again in the future. I'll let you know when we have those calls, okay?
Okay, thank
And
you.
we'll keep talking about it.
Okay, Nathaniel, to complete, I was trying to read from a paper that you must have come across, a comprehensive study, rocket and radar study of mid-latitude SPDF.
Mhm.
That's by GD Early. I think he's in Virginia Tech.
Oh, Greg Earl, yeah.
Yeah, yeah. So like he says in his second paragraph of the paper that waves that perturb the ionosphere may be generated by intense convective activity associated with tropical storms and hurricanes.
Mhm.
Since gravity waves, TIDs, can be launched by convective events in the lower atmosphere by body forces created by dissipating gravity waves in the thermosphere.
Yep.
And by auroral heating at E and F region altitudes. All of these phenomena are candidate sources to perturb the mid-latitude ionosphere and trigger mid-latitude SPDF. That's why SPDF. But this could happen for what we are seeing as well. Okay.
Yeah.
Because one comes after the other.
The data so far, where people have done scientific papers on this, show that big Midwestern thunderstorms that go way up into the atmosphere, ripple the ionosphere, that some gravity waves, atmospheric gravity waves do. And then in Japan, they've done a study when big storm came from the northwest across Japan, that it affected the ionosphere. I think Takahashi, I think, was the guy that wrote that paper and stuff. Anyway, that's the stuff that's been proven, but people generally say, no, when you get down to lower weather, it doesn't have any effect.
Yeah, and in my PhD thesis, I found that the MS medium scale traveling atmospheric disturbances were much more correlated with the polar vortex than they were with the aurora. So that was a big
does that not defeat the purpose of looking at AE index as a precursor of TID?
Well, these are large scale traveling atmospheric disturbances, which are different from medium scale ones. So that's one of the reasons that I'm really looking at the aurora here. So I know John Hayes has to go in a couple minutes. So I wanted to give him a couple minutes to talk before he has to go. So let me turn it over to him, and then we can, and that way he can say what he needs to say.
Well, thank you, Nathaniel. This has been totally fascinating for me. Thanks for the invitation. I'm not an academic, but when I was in the Air Force Space Command, we did very similar research to what you're looking at with the aurora. And we had both space shuttle payloads and we had sounding rockets we shot off from Alaska into the Aurora to take a bunch of measurements. And I actually have nose cone video from the sounding rocket. I mainly wanted to drop by and just introduce myself. Feel free to reach out to me concerning any grant requests that you might have. We have funding, and we're very excited about the work HamSCI is doing. I'll put into the chat my direct contact information. We can fund some pretty interesting projects. We just need a proposal from you. And of course, we do need you to have an educational institution or a 501c3 act as the fiscal sponsor. But given that, we would love to see some more applications from you. And as Nathaniel can attest, we don't want you to go cheap. We want you to get what you need. So any questions, I've got to leave at the top of the hour, but give a chance to pop in with any questions here. Okay, well, thank you, everybody. And I'll be popping out in a minute, but I'll put something in the chat window.
And we do thank you so much for your current support of the Tangerine SDR that you've been helping us out with. And I know with the Case Western antennas. So we're very grateful for all of the support you and your group have been able to give so far. And I can tell you that I am working on the proposals that I've talked to you about, and Dr. Mahal is working on it as well. And so we will be in touch as soon as we can.
Great. I look forward to it. Have the rest of your session, and invite me in the future, because this is totally fascinating. I just happen to have something right up against the back end of it.
Thank you. Robinette, are you there? So I guess to go back to what you were saying, Dev, yeah, so we do believe that, and even what Larry was saying, there's increasing belief that the lower atmosphere does have a significant impact on the upper atmosphere. In fact, I mean, at 2 HamSCIs ago, when last time we had it in real life, Larissa Goncharenko gave one of the invited tutorials, and she gave a great tutorial about what we do know about how the lower atmosphere, the neutral atmosphere, affects the ionosphere so far. So we've been looking at that for quite some time. So, but yeah, still trying to find the actual source of these LSTIDs is a bit perplexing, because certainly if you go read the literature for large scale traveling ionospheric disturbances, which is what I believe I'm seeing in the ham radio data, it does generally say that it's the aurora. But again, like, I'm having a hard time getting things to line up that neatly. It's just not so clean. And so, yeah, I think we have to look at some of these other sources. From the discussion I had on Monday, the MIT Haystack scientists and the Virginia Tech scientists, they recommended that I still go look out in at space measurements from the Omni satellite. So they told me to look at the solar wind data, the interplanetary magnetic field data, the dynamic pressure of the magnetic field of the solar wind. So I'll probably be this weekend working on plotting those, making those plots as well, and getting that ready to show those at the TAPR meeting. So we'll see what turns up from there. And then if that doesn't show anything, or if it shows very small connection, I think we also need to keep looking at these neutral atmospheric things, like what Larry is sending, and see what other types of data sources we can look at. Well, I think that's it for today then. We're coming up to 4 o'clock. Any other questions or comments? David, you never got to say hello at the beginning.
I didn't. I was a minute late because I was scrambling around looking for the Zoom address. So greetings all. I think everybody here knows me. I won't introduce myself. But all I have to say is that John's and my, that's not right. The engineering senior projects, which John and I are supervising, they are not John's and my senior projects. That I don't like the tone or the implications of that. Are moving along well, and in particular, the more we work on it, the more promising I think the Coherent CW project may be. So, watch this space.
Thank you very much. All right, everyone. I'll say 7-3, and Dev, I'll meet you on the other link. Okay.
Okay, no problem at all.
Thanks.
Come through, everyone. Stay healthy. Have a good
Take care,
weekend.
folks. Once again, John, do you have a moment?
Yeah.
All right, hang out with me for a sec.